Have you ever wondered how we got from the rudimentary punch cards of the 1800s to today's sophisticated software systems? The birth of software engineering is a tale of innovation and perseverance. It all started with Ada Lovelace, the world's first programmer, who in the mid-19th century developed mathematical algorithms for Charles Babbage's analytical engine. These algorithms, though never implemented in her lifetime, were essentially the first instance of what we now call a program. Fast forward to the 20th century, the era of mainframes and punch cards. This was when software began to take more recognizable forms. The turning point came from the minds at Bell Labs, who pioneered the concept of structured programming. This was a revolutionary approach that emphasized modularity and reduced complexity, laying the groundwork for many modern programming languages. And so, the seeds of software engineering were sown, but not without its share of challenges. Ever heard of the software crisis? It was a pivotal moment in our story. During the 1960s and 1970s, as computing power increased, software projects became larger and more complex. Developers struggled with project delays, cost overruns, and low-quality software. This period, known as the software crisis, highlighted the need for a more systematic approach to software development. Enter software engineering, a distinct discipline dedicated to applying engineering principles to software creation. This new approach aimed to make software development more predictable and efficient. As part of this shift, new programming languages emerged. C, developed in the early 1970s at Bell Labs, introduced a structured approach to programming. This was followed by C++, an extension of C that added object-oriented programming. Then came Java in the mid-90s, bringing platform independence and network computing to the fore. These languages laid the foundation for the software we use today, but the landscape was about to change drastically. The turn of the century brought a wave of fresh ideas and methodologies that revolutionized software development. Agile methodologies emerged, shifting the focus from a rigid, process-driven approach to a more flexible, collaborative one. Instead of waiting months or even years for a software release, Agile promoted frequent, incremental updates, allowing teams to adapt quickly to changes and customer feedback. Then came DevOps, a philosophy that broke down the barriers between development and operations teams. By fostering a culture of continuous integration and deployment, DevOps significantly accelerated the pace of software delivery. Lastly, the open source movement played a crucial role in democratizing software development. By making source code freely available, it empowered communities worldwide to contribute to and improve upon software projects. It sparked a spirit of collective innovation, as developers from all corners of the globe collaborated to create better, more robust software. These shifts paved the way for the next big leaps in software engineering. From the rise of personal computing to the mobile era, our journey has been marked by exciting milestones. The 80s saw the dawn of personal computing, with companies like Microsoft and Apple introducing user-friendly operating systems. This era was transformative, bringing computers into homes and offices around the globe. No sooner had we adapted to this change, the 90s ushered in the internet revolution. Sir Tim Berners-Lee gifted us the World Wide Web, and our world became a global village. With the internet came e-commerce, social media, and a myriad of opportunities that we continue to explore. Then, the new millennium welcomed the mobile era. Smartphones became our constant companions, and apps the new norm. Influential figures like Linus Torvalds, creator of Linux and Git, played a significant role in this epoch. These milestones have shaped the software engineering landscape as we know it today. So, where does that leave us now, and where are we headed? As we gaze into the looking glass of software engineering, we see a landscape shaped by artificial intelligence and machine learning. These are no longer just buzzwords, but essential tools for software development. They're helping us write cleaner code, spot bugs before they happen, and even automate some aspects of coding itself. And then there's the quest for sustainability. As our digital footprint grows, so does our responsibility to create software that's not just efficient, but also kind to our planet. More and more we're seeing a shift towards practices that reduce energy consumption and waste, from lean coding techniques to green data centers. We're also witnessing a democratization of software development. With open source movements and platforms, anyone, anywhere can contribute to the software they use. As we stand on the cusp of new frontiers in software engineering, one thing remains clear: our journey is far from over.